Subatomic particles. Atoms consist of three subatomic particles: protons, neutrons, and electrons. A proton has a charge of +1 and a mass of 1, a neutron has a charge of 0 and a mass of 1, and an electron has a charge of -1 and a mass of 1/2000. The mass of an electron is so small that it is not included when calculating the mass of an atom. Here you can see a helium atom. It consists of 2 protons, 2 neutrons, and 2 electrons, giving it a mass of 4 and an overall charge of 0. The structure of the atom. The atom consists of a nucleus and orbiting electrons in what is known as shells or energy levels. The nucleus is a concentrated ball of neutrons and protons. This is where the mass of the atom is found. As they are made out of protons and neutrons, nuclei have an overall positive charge. In a normal atom, there is always an equal number of protons and electrons. Therefore, their charge cancels out, giving the atom an overall charge of 0. Note that the proportions and size of this atom is not accurate, as the nucleus is extremely small, and the electrons orbit much further away from the nucleus than what is shown in the diagram. Covalent bonding. Covalent bonding occurs between nonmetals. In covalent bonding, the electrons are shared between each atom to allow each one to have a full outer shell of electrons. This results in the bonds being very strong. The resulting molecule has a neutral charge as no electrons are lost or gained. Covalent bonds can be shown through dot and cross diagrams, such as this hydrogen 2 molecule. Covalent structures can't conduct electricity as there are no charged particles to carry an electrical current. However, some giant covalent lattices have delocalized electrons and therefore can conduct electricity. Ionic bonds occur between a nonmetal and a metal. The metal gives its electrons to the nonmetal, resulting in a full outer shell of electrons for both reactants. This forms positively and negatively charged ions, also known as cations and anions. Ionic bonds are very strong because the ions have strong electrostatic forces of attraction between them. They can be represented by the diagram below. As you can see, the diagram is similar to the dot and cross diagram in the sense that the electrons are displayed through dots and crosses. The sodium atom gave its electron to the chlorine atom, giving both ions a full outer shell. As a chlorine atom gains a negative electron, it produces a chloride ion with a -1 charge. Because the sodium atom gave away a negative electron, it produces a sodium ion with a +1 charge. Ionic compounds cannot conduct electricity when solid because no charged particles are able to move and carry an electrical current. However, when they are molten or aqueous, the ions are free to move and therefore carry a current. Metallic bonding occurs between metals. In metallic lattices, the metal atoms lose their outside shell of electrons and therefore become positively charged ions. These electrons on the outer shell become delocalized and can move freely throughout the lattice. This means that they can carry an electrical current throughout the structure and is the reason why metals are known as good conductors. The reason that the lattice's bonds are strong is that there are strong electrostatic forces of attraction between the ions and the electrons. Thanks for watching. I hope this brief introduction to atomic structure and bonding aided you in your understanding of the different concepts. If you have any questions, feel free to ask them in the comments.